Now in this lesson we are going to answer the questions given in the mock test 5 held on 9 June, that is yesterday. Total number of questions given was 45 and time allotted for your answer was 45 minutes. Let us take the first question. A ball of mass m is thrown upwards with a velocity v. If air exerts an average resisting force F, the velocity with which the ball returns to the thrower is. Now, the ball is thrown with a velocity v. So, the kinetic energy of the ball is half mv square. Now, two forces are acting now on the ball. One of them is the weight of the ball, and the other is resistive force. Resisting force is also in the downward direction. So total downward force acting on the ball is mg plus f, and it ascends a distance x. Then work done against the force equals to change in kinetic energy. So half mv square equals to mg plus f into x. Now the ball is at the topmost point. It will fall due to the attraction of the gravity now. Now the forces are acting on the ball are weight in the downward direction and resisting force in the upward direction. Now the resultant force acting on the ball is mg minus f. And when it is returning back to the thrower, the distance traversed by the ball is x, equals to kinetic energy gained by the ball. When it reached the topmost point, it has lost all the kinetic energy to perform work against the forces acting on the ball, against the forces acting on the ball, that is weight and the resisting force. Now, the kinetic energy gained by the ball is due to the resultant force of mg minus f, mg and f, that is mg minus f. So the work done against this resultant force is mg minus f into x equals to kinetic energy gain, that is half m v1 square, if v1 be the speed of the ball when it returns to the thrower. Now v1 square by v square, dividing equation 2 by equation 1 we get equals to mg minus f by mg plus f, as x being cancelled out and half m being cancelled out from the left hand side and x being cancelled out from right hand side. So v1 equals to root over of mg minus f by mg plus f into v. So our correct answer is C, v into root over of mg minus f by mg plus f. So the correct answer to the question number 1 is C. Now see the question number 2. Two blocks A and B of masses twice m and m respectively are connected by a massless and inextensible string. The whole system is suspended by a massless string as shown in the figure. The magnitude of acceleration of A and B immediately after the string is cut. Here is a string which is connecting A and B, and the whole system are connected by a massless and inextensible string. Two blocks A and B of masses 2m and m respectively are connected by a massless and inextensible string. Here is the string. The whole system is suspended from a massless spring. Here is the spring in the upward portion. The magnitude of acceleration of A and B immediately after the string is cut. When the string is cut, the mass B will be free. So its acceleration is acceleration due to gravity. For the upper mass, there are two forces acting. That is the downward force, weight of the mass. And number 2, the reaction force, that is due to this weight of the mg. So that is R equals to mg in the upward direction. Hence the resultant force acting on the mass B is 2mg minus mg. Resultant force equals to mass time acceleration into A of B, acceleration of B. So AB equals to mg divided by twice m equals to g by 2. So the acceleration of A is g by 2 and B is g. So the correct answer is B. So answer to the question number 2 is B. Now let us see the third question. An object is kept on a smooth inclined plane of 1 in L. The horizontal acceleration to be imparted to the inclined plane so that the object is stationary relative to the incline. Now, here is the inclined plane. An object is here and the object should fall through the plane due to the component of weight, that is mg sin theta. Now an acceleration is given to the system so that a pseudo force will act. System is given an acceleration f towards the right, so pseudo force mf will act towards left. And if the angle of inclination is theta, then the component of pseudo force against the gravitational component of gravitational force is mf into cos theta. For equilibrium, we find that mg sin theta equals to amf cos theta. Hence, f equals to, what is there? M being cancelled out, f equals to g tan theta. Now, inclination is 1:L. So, this is 1, perpendicular is 1, hypotenuse is L. So, base is root over L square minus 1. So, tan theta, we may get tan theta, sin theta is 1 by L, sin theta is 1 by L. So, we will get tan theta as 1 by root over of L square minus 1. So, f equals to g by root over of L square minus 1, f equals to g into 1 by root over of, so g by root over of L square minus 1. So our correct option is C. So the correct answer to the question number 3 is C. Now let us see the question number 4. It is also a question from mechanics. A body of mass 40 kg resting on a rough horizontal surface subject to a force F which is just enough to start the motion of the body. If mu s is 0.5 and mu k is 0.4, the force F is continuously applied on the body, then the acceleration of the body. Now, just the force applied, just moving the body. So, the force is just greater than the limiting value of static friction. That is, F equals to, we know that limiting value of static friction, F equals to mu r or mu s into r, that is mu s into mg. And this force is acting on the body. But when it is moving, frictional force is kinetic friction, and that is mu k into mg. So the resultant force acting on the body is mu s into mg minus mu k into mg. You have to calculate the acceleration of the body. This is the resultant force equals to m into a. So we have to calculate a here. We have to calculate a here. M being cancelled out from both sides. A equals to mu s, that is your 0.5. Mu s is 0.5 and mu k is 0.4. So 0.5 into g minus 0.4 into g, that is 0.1 into g. G is 10, so 0.1 into 10, that is your 1 meter per second square. So the answer to the question number 4 is B. Now let us see the question number 5. Question number 5. In question number 5, we see that a particle of mass 5 kg moves in a circle of radius 20 centimeter. Its linear speed at a time t is v equals to 40. T is in second and v is in meter per second. The net force acting on the particle. The particle is moving with a variable speed. So both the forces will act. That is the tangential force, AT, m AT, and the radial force m into ar. Both of them will act, and the actual force acting is the resultant of these two forces. Here V equals to A into T. V equals to 40, sorry. So dV dt equals to 4. So m into AT, m is your 5 kg, so m into AT is 5 into 4, that is your 20 Newton. So the tangential force is 20 Newton here. Now, the radial force is mv square by r. We are to calculate the force at time t equals to 0.5 second. At 0.5 second, the velocity is v equals to 40, t is 0.5, t is half. So v is 2 meter per second. Then mv square by r. M is 5 kg, v square is 2 square. By r, it is revolving in a circle, moves in a circle of radius 20 cm, that is 1/5 meter. So r is 1/5 meter, 20 centimeter means 1/5 meter, that is equals to 5 into 5 into 2 square, 5 into 5, 25 into 4, 100. So this is MAR, that is your radial force, and tangential force is 20 Newton. These two forces are mutually perpendicular, so the resultant force R square equals to FR square plus FT square. FR square is 100 Newton square plus Ft is 20 Newton its square, so R equals to, keeping 20 square common, 5 square plus 1, that is 26, that is your 20 root 26. So our answer is 20 root 26. So the correct answer to the question number 5 is D. Now let us see the question number 6. In the system shown in the figure, tension T3, we see there are 3 masses hanging from the top, and there are 3 masses of 1 kg, 2 kg and 3 kg respectively. We have to calculate just T3 only, that is upward tension. The whole system is in equilibrium. So upward tension is actually, tensional force is actually supporting total whole the system, whole mass of the system, that is 6 kg weight is actually balanced by T3. So T3 equals to actually 6g. As the system is in equilibrium, total downward force is 6 kg mass being supported by T3. So total downward force is 6g and upward force is T3. So T3 in equilibrium, T3 equals to 6g. Correct answer is D. So the correct answer to the question number 6 is D. Now let us go to the question number 7. In question number 7, we see that it is a question from vector algebra. Two equal forces are acting at a point at an angle 60 degree between them. If the resultant force is 40 root 3 Newton, then each of the force. We know that if P equals to Q, two forces, and the angle in between them is 60 degrees, then the resultant R equals to P root 3. So here R is 40 root 3. So 40 root 3 equals to P root 3, which implies that P equals to 40 Newton. So the correct answer to the question number 7 is A. Let us take the question number 8. What does it say? A man moves 20 meters north, then 10 meter east, then 10 root 2 meter southwest. His displacement is. When successive displacements are given, then to calculate the total displacement, we will actually represent all these vectors as co-initial vectors. First, the man moves towards north for 20 meters. Then 10 meter east. Then 10 meter east. They are represented by respectively OA and OB vector. And then 10 root 2 southwest. Southwest 10 root 2 meter due southwest. So OA, OB and OC are 3 co-initial vectors. They are representing the successive displacements. Now we will divide these forces along east-west and north-south line. Two forces are already directed due east and due north, so OC should be resolved in these two directions. Towards the west, the component is 10 root 2 cos 45 degree, that is 1 by root 2, that is also 10 meter. And due south, it is 10 root 2 sin 45 degree, that is 1 by root 2 equals to 10 meter. Now let us see what happens. Towards east, 10 meter, towards west, 10 meter. They will nullify each other. Towards north, displacement is 20 meter, and towards south, it is 10 meter. So the net displacement is 20 minus 10 meter, that is 10 meter due north. 10 meter due north. So our correct answer is C. So the correct answer to the question number 8 is C. Now let us see the question number 9. In question number 9, we see that a particle is projected with an initial velocity 200 meter per second in a direction which makes an angle 30 degree with the vertical. A particle is projected with velocity 200 meter per second at an angle 30 degree with the vertical. The horizontal distance traveled by the particle in 3 seconds. So the horizontal component of velocity is 200 sine 30 degree, that is your 100 meter per second. And in the horizontal direction, it will move with uniform speed. So distance traveled in 3 seconds, that is S equals to Vt equals to V is 100 and T is only 3 seconds, that is your 300 meter. So the horizontal distance traveled is 300 meter. We find it in option number C. So the correct option to the question number 9 is C. Now let us see the question number 10. In question number 10, a particle moves in the xy plane with velocity Vx equals to 8t minus 2 and Vy equals to 2. If it passes through the point x equals to 14 and y equals to 4 at t equals to 2 seconds, then equation of the path, we have to find the equation of the path. Here, component of velocity along x direction, Vx equals to 8t minus 2 and that is Vy equals to 2. Vx means that is dx dt. So dx equals to 8t minus 2 into dt. Vy means dy dt equals to 2. So dy equals to 2 into dt. We are to integrate two equations. Then x equals to 8t square by 2 minus twice t plus c1. And time given is 2 seconds. So at t equals to 2, x is given as 14. X equals to 14. So 14 equals to 40 square. 4 into 2 square minus 2 into 2 plus c1. 16 minus 4 plus c1 equals to 14. So c1 equals to 14 minus 12 equals to 2. So x equals to what? 40 square minus twice t plus 2. Now we have to find y. Now y equals to twice t plus c2 plus C2. Now at t equals to 2, y equals to 4. So y equals to 4 at t equals to 2, which implies that C2 equals to 0. Hence y equals to twice t. And to find the equation, we have to put in the first equation t equals to y by 2. So we have to put it there. So x equals to 4 into y by 2 whole square minus 2 into y by 2 plus 2. That is your y square, x equals to y square minus y plus 2. So B is our correct answer. So the correct answer to the question number 10 is B. Now let us go to the question number 11. In question number 11, we see that a body is moving with velocity 30 meters per second towards east. After 10 seconds, its velocity becomes 40 meters per second towards north, the average acceleration. The body was initially moving towards east and it is represented by OA. This is 30 meters per second. And finally, this is, let it be U. And finally, its velocity becomes 40 meters per second due north after 10 seconds. So, velocity becomes 40 meters per second due north. That is represented by OB and it is given by V vector. Average acceleration, A average, equals to what? V minus U by T. So, OA is representing U. Then, its opposite vector OC is representing minus U. So the resultant of V and minus U vector is given by OE vector. So OE vector, U equals to 30 meters per second. So OC is actually representing the vector 30 meters per second. OB is 40 meters per second. Their resultant OE is actually giving OE square equals to 30 square plus 40 square. So OE equals to 50. So V vector minus U vector, the magnitude of V vector minus U vector is actually 50. OE square is 30 square plus 40 square. 30 square means 900, 40 square means 1600. So OE square equals to 2500. So OE equals to 50. Now, average A average equals to mod of V minus U by T. Mod of V minus U 50. T is given here 10 second. 50 by 10, that is your 5 meters per second square. Correct option is D. So the correct answer to the question number 11 is D. Now let us see the question number 12. It is also a question from mechanics. In the given figure, A equals to 15 meters per second square represents the total acceleration. Total acceleration, here is total acceleration is given of a particle moving in a clockwise direction. It is moving, a particle is moving in a clockwise direction in a circle of radius 2.5 meters at an instant of time, the speed of the particle. Now, the central line makes an angle 30 degrees with the total acceleration. So, if we consider about the centripetal force, then centripetal acceleration, then that should be A cos 30 degree. A cos 30 degree. That should gives our centripetal acceleration, and which is equals to V square by R. Now, A is 15. Cos 30 means root 3 by 2. Equals to V square by R. R is 2.5 meter by 2.5. So V square. What is V square? V square equals to 2.5 whole square into 3 root 3. So V equals to 2.5 into root over of 3 root 3. That is nearly 3 into 1.732. That is your 2.5 into 5.196. That is 5.2 nearly. That is nearly 2.27. 2.3 is 5.29. So 2.2 is 4.84. Square root of 4.84 is 2.2 and 5.29 is actually 5.1. 2.2 square is 4.84 and 2.3 square is 5.29. So here the value should be in between 2.2 and 2.3 and near to 2.3. Let it be 2.27. And multiplying 5 into 7 into 25, 175, 17, carry 17, 50, 67, 6, 50, 56, 5.675. nearly 5.7 meter per second. So the velocity is 5.7 meter per second. So our correct answer to the question number 12 is C. Now let us see the next question. That is our question number 13. In question number 13, we see that a train moving at a speed 220 meter per second towards a stationary object emits a sound of frequency 1000 Hz. Some of the sound reaching the object gets reflected back to the train as an echo. The frequency of the echo is detected by the driver of the train. Now, here is the problem. A train is moving at a speed 220 meter per second with a frequency of sound emitted 1000 Hz. Some of the sound reaching the object gets reflected. During reflection, there is no change in frequency. Back to the train, the frequency of the echo detected. So, at first, a sound will be detected by the reflector, and then the source is approaching towards the reflector. And now, in order to hear the reflecting sound, now the observer is at the train. So, the observer is actually approaching towards the train, towards the source of sound, So, in the first case, reflector is actually getting a sound of frequency N1 equals to V by V minus Vs into N. And observer is now approaching there. So, the sound heard by the observer is V plus V0 or V plus Vs by V into N. 1. Source is now emitting a sound N1. Observer is hearing a sound N2. N2 equals to V plus Vs by V into N1. Putting the value N1 here, we see that the expression becomes N2 equals to V plus Vs by V minus Vs into N. Now V plus Vs, V is 330 meter per second and Vs is 220 meter per second. So 330 plus 220 by 330 minus 220 into 1000 Hz. That is 550 by 110 into 10 to the power 3. So 5,000, 5 into 10 to the power 3, 5,000 Hz. So the sound heard, ultimately the frequency of echo detected is 5,000 Hz. So C is the correct option. So the correct answer to the question number 13 is C. Now let us take the question number 14. In question number 14, it is also a question from wave course. The fundamental frequency of a closed organ pipe of length 20 centimeter equal to the second overtone of organ open pipe at both the ends. The length of organ pipe open at both the ends. The fundamental frequency of a closed organ pipe, that is V by 4L. 4L. L is 20 centimeter. So N equals to V by 4 into 20. Mind that L is given in centimeter. Now, second overtone. Second overtone means third harmonics of the second overtone means third harmonic of a open organ pipe. For the open organ pipe, fundamental frequency is V by 2L. Second overtone means third harmonics. So the frequency is 3V by 2L equals to V by 4 into 20. V being cancelled out. Now we have to calculate L. So L equals to 3 into 4 into 20 by 2, 10, 120 centimeter. So the correct option is A. Correct option to the question number 14 is A. Now let us